Alright, this video is going to talk about how to compare fractions and figure out if they're equivalent or not. This is objective NF3, so if you head to learnzillions.com or just search the web for this objective, you can also find more videos and resources. Alright, equivalent we've talked about is just a fancy word for equal. You see that same kind of root prefix there, equa, just means equal. So if they ever ask you is 1/2 equivalent to 3/6, they're just trying to figure out, are they the same amount? Are they equal? Okay, now we have talked about this common multiplier, and we've talked about when you have something in common with a friend or a neighbor, it means that there's something the same about you. So be sure to remember that. Whatever we multiply the denominator by, we're going to have to multiply the numerator by the same thing. We have to keep them in common or the same. Alright, the first thing we're going to do is start with what's given to us. 1/3 is equal to, and we have to figure out how many ninths would make it equal or equivalent. So we have to say 3 times what is going to equal 9. Okay, and we know that that is 3. So this is what's called the common multiplier. So because I'm going to multiply the denominator by 3 to equal this new fraction, I need to do the same thing up top in order to keep them equal or the same. So 1 times 3 is 3. So 1/3 is equal to 3 ninths. Okay, next one, same thing. 8 times what equals this 16? And I know that that is 2. So this is the common multiplier. Now I multiply the top by the same thing. So times 2. 2 times 2 is equal to 4. So 2/8 is equal or equivalent to 4/16. Last example, same thing. 4 times 2 equals 8. So I also multiply the top by 2. 3 times 2 is 6. 3/4 is equal or equivalent to 6/8. It's pretty easy. The one thing you have to always remember is that whatever you're multiplying this bottom by, in order to equal this whole here, you must multiply the top by the same thing in order to keep the measurements equal. Okay? Now, what if they give you two different fractions and it's your job to determine if the fraction's greater than, less than, or equal to? What do you do now? You can still use the common multiplier to help you. So you still would say 3 times what is 6? Well, 2. So I'm going to come up here and I have to use the same multiplier. So 2 times 2 equals. Pretend this isn't here. What I need this to say in order for it to be equal is 4, because 2 times 2 is 4. Now, if it doesn't say 4, then I'm going to compare and see, is this number more than 4 or less than 4? Okay? In this case, it is 4, so these are equal, because 3 times 2 is 6, and 2 times 2, which is the common multiplier, is 4. Okay? Again, 8 times 2 is going to equal 16, so I must also use times 2 up here. 1 times 2 is 2. So I first of all know that these are not equal because they said that this is 4/16. And it would have to be 2/16 in order for them to be equal. So I know that they're not equal. Now I have to compare. Is this one greater than or is it less than? Well, this is a 1. And in order for them to be equal, this should be a 2. But it's more than 2. It's 4. So in this case, 4/16 is greater than 1/8. Because again, 2 is what I need the numerator to be for them to be the same or equal. And it's actually more than that. It's 4. Alright, down here, another example. 9 times 3 equals 27. So I must multiply 2 times the 3. 2 times 3 is 6. Okay? I automatically know that these are not equal because this is 9, and it would have to be a 6 in order for them to be equal. 9 is more than 6, so this one, 2, is greater than 2/9. Last one, 4 times 3 is equal to 12, so I must multiply the top by 3. 3 times 3 is 9. Okay? Because this is not 9, these are not equal, but this is greater than the 9, so this fraction must be larger. Okay, you could also use pictures as always to help you. If I were to draw 2/3, so I had 1, 2, 3 equal pieces. I'm going to shade 2 of them, and then using the same size bar, I'm going to break this into sixths. Okay, so I have 1, 2, 3, 4, 5, 6 equal pieces. I'm going to shade 4 of them, and you can see that they are indeed equal. Okay, if I wanted to draw this as an example, I would draw a bar, cut it into eighths. 4, 5, 6, 1, 2, 3, 4, 5, 6, 7, 8 equal pieces. I would shade 1 of them. The key is drawing the same size bar. Now I'd have to cut this into 16ths. And remember, as this denominator grows in its size, the pieces are going to become smaller because I now have to fit 16 in here. So I had to draw 15 lines. Now if I shade 4, you can see that it is larger. Barely, but it is. Okay? So pictures can help you, but the common multiplier is going to be easier. It's also going to be faster, and it's also going to be more accurate than us trying to hand draw. Okay?